The multiverse, fact or fiction. Parallel universes, the idea of alternate realities where everything could be different, from the moment you finally plug in your asymmetric computer cord correctly to an ideal world where the Star Wars prequels were never made, captivate our imaginations. But what's the scientific standing on these far-out ideas? Do they have a place in physics, or are they just wistful speculations with no evidence to back them up? Let's dive into the science behind these alternate worlds, specifically the concept of the multiverse. What is the multiverse? When physicists discuss the multiverse, they're typically referring to one of three proposed models of the universe. Despite its allure in pop culture, there is no experimental evidence that confirms the existence of a multiverse just yet. The three models of the multiverse are bubble universes, baby black hole universes. This is one of the most straightforward models. The idea is that there may be parts of the universe so far away or hidden inside black holes that we'll never see them. These distant parts could be governed by different physical laws, and if we exist in a bubble with the right conditions for life, that could explain why our universe is so well suited for stars, galaxies, and life. But as exciting as this theory sounds, there's no experimental evidence to back it up. Yet. Membranes and extra dimensions. Inspired by string theory, this model suggests that what we perceive as our universe might just be a three-dimensional surface, a brain, embedded in a higher dimensional space. Imagine a newspaper page. Each page is a two-dimensional surface existing within a three-dimensional world. Similarly, if space had 9 dimensions instead of 3, it would allow for other membranes or universes to exist alongside ours, each seemingly separate but part of a greater whole. Like the bubble universe model, this concept is speculative and lacks experimental confirmation. Many worlds' interpretation of quantum mechanics, this one is particularly fascinating. It proposes that every possible alternate timeline for the universe is real and happens in parallel. This model suggests that every possible outcome of a quantum event creates a new branch of reality. In essence, there could be a version of you living out each of your potential life paths from the mundane to the extraordinary. But just like the other models, there's no experimental evidence proving that we live in a many-worlds multiverse yet. Testing the multiverse hypotheses, so is there any way to test these speculative models? Surprisingly, yes. Observing collisions of bubble universes. If our universe is just one bubble in a larger multiverse, it might have collided with another bubble at some point in the past. Such a collision could have left detectable effects on our observable universe, particularly in the cosmic microwave background, the afterglow of the Big Bang. If these bubbles did collide, we might be able to see evidence of it in the night sky. However, until we have the technology to observe these minute details, this hypothesis remains untested. The many worlds model and quantum mechanics. While the bubble universes and membrane theories are largely speculative, the many worlds interpretation could be tested soon. Experimentalists are now able to manipulate large quantum mechanical systems in the lab, which are starting to approach the line between the quantum world and our everyday experience. If we can observe quantum events creating parallel timelines, we might just find the proof we need for the many worlds hypothesis. Conclusion: physics versus philosophy. It's important to remember that physics is science, not philosophy. The multiverse, though a fascinating concept, remains speculative until we can test these ideas. Whether we're talking about bubbles, membranes, or quantum mechanics, the key is to remember that the models must be testable. Only through experimentation and observation can we validate, or invalidate, these ideas. For now, we're left with the mystery of the multiverse, an exciting but unconfirmed part of the scientific landscape. But who knows? With advancements in quantum mechanics and cosmology, We might just be on the brink of uncovering the answers to one of the universe's most intriguing questions. Are there other universes? And if so, what are they like?